Okay, sample problem 2.2. Determine the numbers of protons, neutrons, and electrons in each of the following species. Cl1735, Cl1737, K41, and carbon 14. So this is an issue of what we call isotopes. It's kind of a fun little thing. Isotopes are generally concerned with the issue of the nucleus of an atom. Remember, the atom has a dense, positively charged center, which is called the nucleus. And then there are light particles outside of the nucleus, which are called electrons. So there could be 1 electron, or there could be 30 electrons, but there's electrons. So the electrons are outside. Remember, the electrons are negatively charged. And then in this tiny little center, that's called the nucleus. This is called the nuclear model. And that's where the protons are. Protons are positively charged. And that's where the neutrons are. No charge at all. Okay? Those are the 3 subatomic particles that make up the atom in our universe. Now, the notation here involves the nucleus. So be careful. When you use a periodic table, the notation is different. This is not notation you'll see in the periodic table. This is what's called isotopic notation. Isotopic notation. Okay? In isotopic notation, the number down here at the bottom is the atomic number. The number up above, top heavy, that number is usually larger than the one at the bottom, so it's top heavy. That one is the mass number. These 2 particles here, the protons and the neutrons, those are often referred to as nucleons. A nucleon is a particle that is in the nucleus, and those are both in the nucleus, so they're called nucleons. The mass number is the number of nucleons in the atom. One atom of this isotope. Okay? So the bottom number, the atomic number, is the number of protons. In one atom. Very simple. We're just counting protons and neutrons and indicating them there. The number of electrons is not indicated in this notation, but it can be inferred based on the following principle. In what are called neutral atoms, atoms are by definition neutral, the number of protons is equal to the number of electrons. So in a sense, the atomic number gives you 2 for the price of 1. It gives you the number of protons, but because the number of protons is equal to the number of electrons, it also gives you the number of electrons. So let's go through this isotopic notation. I'm going to start with chlorine 1735. We're going to count up the number of nucleons, which is the mass number. From that information, we're going to get the number of protons, neutrons, and then from that we'll also get the number of electrons. Very simple exercise. So let's begin it with chlorine 35. That's a 35. Number of nucleons, that's the mass number, 35. Number of protons, that's this number down there, 17. The number of neutrons is very simply calculated. If the mass number is 35, and that's the number of protons and neutrons, and the number of protons we've already determined is 17, number of neutrons would just be 35 minus 17, which is 18. 18 neutrons. And then again, the atomic number also gives us the number of electrons, so that's 17. Okay, does that make sense? Hopefully it does. The rest of this problem is just dealing with the notation. So in the second one, they give us chlorine 1737. So it's another form of chlorine, right? It's still chlorine. What makes an element, so what makes chlorine chlorine is actually the number of protons, interestingly enough. That's just the way atoms are designed. So any atom that has 17 protons is chlorine. So again, here's our mass number, 37, but the number of protons is 17. It's chlorine, so it's got to be 17. And then the number of neutrons would be 37 minus 17, which is 20. And then again, the number of protons is equal to the number of electrons, so that's 17. The next one is potassium 41. Now this one, they don't give us all the information. Not cool. So we actually have to do a little research on this one. We do know the mass number is 41, but we don't know the atomic number. So you look it up in a periodic table. Go to the periodic table, and what you'll find is that potassium is element number 19. That number above there is 19. So it's really, there should be a 19 there. So it's got 19 protons. Again, the number of electrons is equal to the number of protons, so we already have that one. And then the mass number minus the atomic number, that's going to give us the number of protons. Number of neutrons, sorry, neutrons. The number of neutrons can vary within an element. So there can be potassium with 24. I don't think I did that calculation right. I'm sorry. This is 19. So that's 22. The number of neutrons can vary within an element. So there can be potassium with 22 neutrons, or maybe 21 neutrons, but the number of protons cannot vary in potassium. Potassium, if it is potassium, it has to have 19 protons. If it had 18, it would be a different element, argon. If it had 20, it would be calcium. Okay. Last one is carbon 14. This is just using a different notation. Carbon, you may need to look that up, is a C. The 14, when you see 14, when you see the number written hyphenated and written after the name of the element, that's the mass number. Go back to the periodic table, and you'll find that carbon is element 6, so it has 6 protons. So the mass number is 14, 6 protons, of course 6 electrons, and then 14 minus 6 is your 8 neutrons. Okay, there you go. That's isotopic notation. In nature, each element has more than one isotope found in nature. There's usually a dominant 1 or 2, but each element actually has more than one isotope in nature. Very interesting.